On the 1st of July 2025, astronomers using the Asteroid Terrestrial Impact Last Alert System, or ATLAS, detected a fast-moving object on a sharply hyperbolic orbit, soon confirmed as 3I Atlas, the third known visitor from our solar system. Back in 2017, 1I Oumuamua's peculiarity led Harvard astrophysicist AVI Loeb to suggest it might have been an artificial probe. Loeb is now making a similar case for 3I Atlas. Now, NASA has finally responded to claims that 3I Atlas is an advanced alien spacecraft. There's a lot to unpack. Let's get started. 3I Atlas. What we know so far? 3I Atlas is the third interstellar object ever confirmed to pass through our solar system, following 1I Oumuamua in 2017 and 2I Borisov in 2019. At the time of its discovery, this visitor was about 4.5 astronomical units from the Sun, roughly the distance of Jupiter's orbit. Astronomers quickly calculated its path and found it to be hyperbolic, meaning it is not bound to the Sun and is only visiting once before heading back into interstellar space. Its orbital eccentricity is about 6.1, far higher than the value of 1 that separates bound orbits from unbound ones. It will reach its closest point to the Sun, about 1.36 astronomical units, on the 29th of October, 2025, then move outward again. The object is moving extraordinarily fast, traveling about 58 kilometers per second relative to the Sun, which equals roughly 130,000 miles per hour. Its orbital inclination is nearly 175 degrees, meaning it moves on a steep, retrograde path, almost opposite to the general direction of planets and most asteroids. These figures alone confirm that 3I Atlas came from far our solar system. NASA's Hubble Space Telescope and other observatories show that the object is surrounded by a glowing coma of dust and gas, evidence of active sublimation as sunlight warms its surface. Early estimates place the nucleus at no more than 5.6 kilometers across, though it could be as small as about 440 meters. Most of the light we see comes from the surrounding dust, making precise size measurements difficult. The more we get to know about this visitor, the more it astonishes us. 3I Atlas began to show comet-like activity while still very far from the Sun. Data from the Zwicky Transient Facility indicate that it brightened as early as 9 astronomical units from the Sun, a distance where water ice remains frozen. This suggests the presence of more volatile materials such as carbon dioxide and carbon monoxide. NASA's James Webb Space Telescope confirmed this in August 2025, detecting a coma dominated by carbon dioxide along with water, carbon monoxide, and dust. The ratio of carbon dioxide to water is about 8:1, far higher than typical comets in our solar system. Back in 2017, Oumuamua followed a hyperbolic path with an eccentricity of about 1.2 and an inbound velocity near 26 kilometers per second relative to the Sun. Unlike 3I Atlas, Oumuamua showed no visible coma or tail, leaving scientists to debate whether it was an asteroid, a comet that had lost its surface volatiles, or even something stranger. By contrast, 3I Atlas clearly behaves like a comet, with strong outgassing, a bright coma, and well-defined chemical signatures. 2I Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov in Crimea, was more like 3I Atlas. It too displayed a prominent coma and tail, leaving little doubt that it was a comet. Its eccentricity was about 3.36, and its speed relative to the Sun was about 32 km per second, noticeably slower than 3I Atlas but still unbound. Spectroscopic studies of 2I Borisov revealed a composition similar to solar system comets, including water, carbon monoxide, and dust, though with some unique ratios that hinted at different conditions in its home system. In many ways, 3I Atlas looks like a larger, more volatile-rich cousin of 2I Borisov, but moving nearly twice as fast. These comparisons matter because each interstellar object gives astronomers a rare sample of material from another planetary system. Oumuamua showed that not all interstellar visitors behave like typical comets. 2I Borisov and 3I Atlas, on the other hand, demonstrate that icy, volatile-rich bodies can survive long journeys between stars. The chemical signatures of 3I Atlas, particularly its carbon dioxide dominance and unusual polarimetric properties, suggest it formed in a very cold environment where carbon dioxide ice could remain abundant. Or maybe it's something else entirely. Maybe we're missing an important piece of the puzzle. AVI Lab's hypothesis. Back in 2017, when the object later named 1I Oumuamua was discovered by Pan-STARRS in Hawaii, Harvard University astrophysicist AVI Lab raised questions about its nature. He pointed out that Oumuamua showed non-gravitational acceleration, that is, its trajectory deviated slightly from that predicted only by gravitation from the Sun and planets. He also observed that Oumuamua manifested no visible cometary tail, despite approaching the Sun. These anomalies led him to explore whether radiation pressure from sunlight might explain the acceleration if Oumuamua had an unusually high area-to-mass ratio, perhaps being shaped like a thin sheet or disk. Lub co-authored a paper with Shmuel Bialy in October 2018 proposing this solar radiation pressure hypothesis. They estimated that to explain the observed acceleration, the mass-to-area ratio of Oumuamua would need to be on the order of 0.1 grams per square centimeter. Lub is a career scientist with a strong background. He is the founder of the Galileo project, which aims to search for evidence of extraterrestrial technological artifacts. He is also a fellow of the American Academy of Arts and Sciences and the American Physical Society, among others. His books Extraterrestrial: The First Sign of Intelligent Life, Earth and Interstellar, The Search for Extraterrestrial Life and Our Future in the Stars elaborate his viewpoints on the possibility that some interstellar objects may be artificial in origin. Lub has persisted in arguing that some unexplained features warrant considering artificial origin hypotheses. He has also claimed that the statistical properties of Oumuamua's velocity relative to the local standard of rest are unusual. It appears to have had very low radial and vertical velocity relative to nearby stars, which Lub argues is less likely if its motion were purely natural. When 3I Atlas was discovered, Lub again raised hypotheses that go the standard natural comet interpretation. One of his core claims is that 3I Atlas's trajectory and parameters may be difficult to reconcile with a purely natural object, and that some features are suggestive of an object sent intentionally, possibly a probe or artifact of advanced extraterrestrial intelligence. Lub has pointed out that the orbital plane of 3I Atlas is retrograde, meaning it moves opposite to the general motion of solar system planets, but is tilted only about 5 degrees from the ecliptic, that is, the plane of Earth's orbit around the Sun. He calculates that the odds of an interstellar object, by chance, having such alignment are very small. Another of his claims is related to timing and observation geometry. Lub observes that 3I Atlas's perihelion, or the point of its closest approach to the Sun, around the 29th of October, 2025, will occur at a time when, from Earth's perspective, the object is near the Sun, meaning it will be harder for Earth-based telescopes to observe it when it is brightest. Lub has suggested that this could be a strategic or deliberate characteristic if the object were hiding certain features during its brightest phase. Lub also argues that 3I Atlas's high speed is another feature that demands scrutiny. He claims that such speed, combined with other factors, could offer benefits for stealth or reconnaissance if the object were an artifact. For example, a high velocity makes interception or study more difficult, and moving quickly reduces exposure time to scrutiny. In addition, Lub claims that the path of 3I Atlas brings it relatively close to 3 planets, Jupiter, Mars, and Venus. He proposes that these close passages might enable or facilitate deployment of gadgets by a hypothetical extraterrestrial intelligence. He uses these close approaches to strengthen his argument about how the trajectory could be beneficial for an intelligence wishing to observe, monitor, or interact covertly. Despite all of this, Lub has also publicly stated that he considers the possibility that 3I Atlas is a comet to be the simplest hypothesis. He frames much of his more provocative argument as a pedagogical exercise in pushing boundaries and testing assumptions. Well, there is a basis for that kind of thinking. Alien probes, Fermi paradox, and the zoo hypothesis. In 1950, during a lunchtime conversation at the Los Alamos National Laboratory, physicist Enrico Fermi famously asked, "Where is everybody?" He was referring to the apparent contradiction between the high probability of extraterrestrial civilizations and the complete absence of any confirmed evidence of their existence. Our Milky Way contains an estimated 100 to 400 billion stars, and astronomical surveys such as the Kepler mission have shown that many of those stars host planets within their habitable zones. Life on Earth arose relatively quickly after the planet cooled, and intelligent life developed within. Roughly 4.5 billion years of Earth's formation. These numbers suggest that other intelligent species should have had plenty of time to evolve, develop technology, and explore the galaxy, yet humanity has found no undeniable signals or artifacts. This is the Fermi paradox. But maybe there are others. And we simply don't see them. Advanced civilizations might rely on physical exploration rather than direct communication. Researchers have explored the possibility that interstellar travel by robotic devices, sometimes described as self-replicating probes, could be far more efficient than sending radio messages across the void. Keith B. Wiley's 2011 paper The Fermi Paradox, Self-Replicating Probes, and the Interstellar Transportation Bandwidth calculated that a single fleet of such machines, capable of making copies of itself using local materials, could spread through the Milky Way within only a few million years. This may seem like a lot, but remember, life on Earth is 4.5 billion years old. If even one civilization in the galaxy developed this technology, it could theoretically have seeded probes throughout the stars long before humans evolved. The absence of obvious probes, therefore, deepens the paradox. Some scholars imagine that these hypothetical machines would not simply wander aimlessly. In a 2018 paper, astronomer John Gertz suggested that a network of nodes, or essentially interstellar relay stations, could be positioned around the galaxy to collect data, watch emerging civilizations, and pass along information to their creators. These nodes might communicate with one another using tightly focused beams or other methods invisible to us. Earth could already lie within the watchful sphere of such a network without ever noticing a thing. Physical artifacts, according to this model, might be more reliable than fragile radio links for monitoring distant planets over millions of years. Another influential explanation is the zoo hypothesis, first articulated by radio astronomer John A. Ball in 1973. Ball proposed that advanced extraterrestrial societies may indeed be aware of humanity but deliberately avoid overt contact, much like zookeepers trying not to disturb the animals they observe. Thus, when Harvard astrophysicist Avi Loeb argued in his 2021 book Extraterrestrial that Oumuamua might have been an artificial object, perhaps a thin solar sail propelled by radiation pressure, he was not talking in a void. 2 years later, in August 2019, astronomers in Crimea detected 2I Borisov, another interstellar object, which behaved far more like an ordinary comet, displaying a bright coma and tail rich in familiar volatiles. That discovery reassured many researchers that interstellar objects can be natural and cometary. Now attention has turned to 3I Atlas. Loeb argues that if a civilization wanted to send reconnaissance probes, small natural-looking objects would be an efficient and discreet way